Nate Plank.
I'm Nina Kobzarek.
We're group 18B. This is problem 920. To solve this problem, well, first, here's the problem. We have a truss, a simple truss, with a 5-kip loading on the bottom side of it. It's 8 feet by 6 feet. And so it should be fairly easy to recognize that this is a 3, 4, 5 triangle with 4 on this side, 3 on this side, and 5 on this side. From that, we know that this member must be 10 feet. Now, to solve this problem today, we'll be using the method of virtual work, the equation for which is 1 kip times the displacement at the point we're looking for equals the sum of virtual work times virtual forces times normal forces times length, all divided by the cross-sectional area and the modulus of elasticity. Okay, so let's find the real normal forces. First, we have to start by drawing a free body diagram. At point A, we know that we have stationary support, so we have 2 reactions. At point B, we know that we have 5 kip load. And then at point C, we have a roller, so we know we have 1 reaction. Now then, to find our reactions at our supports, we'll use 2 equations. We'll use the sum of the moments about A, and then we'll also use the sum of the moments, or the sum of the forces in the y direction, vertical direction. So the sum of the moments about A is equal to 0. And to find the sum of the moments about A, we take our 8 feet times our 5 kips plus our force at C but since our force, we can assume that our force at C is in the upward direction, which is a negative direction. So therefore, we'll use a minus in our equilibrium equations. So we have minus force at C times the distance it's acting in, so 8 plus 8 is 16 feet. Solving for the force at C, we get that the force at C equals 2.5 kips. Now then, from this force, we can determine the forces at A. Now then, the forces in the y direction all have to be in equilibrium. So they all have to equal 0 when you sum them. So we have 5 kips in the positive direction, which is down, plus or minus 2.5 kips because it's in the negative direction, which is up. And then we can also assume that the force A is in the negative direction, acting upwards. So minus the force of A. So therefore, the force of A equals 2.5 kips. This should also be apparent due to symmetry of the truss. Now then, our force in the horizontal direction at A is 0, simply because there are no external forces acting in the horizontal direction on this truss. So therefore, this is just 0. I'll just get rid of it completely right now. Okay, so now that we have our reactions of 2.5 kips and 2.5 kips, we can take the method of joints to solve for the individual truss members. But before we do that, we should notice that right away, there are no forces in EF or AF, and by symmetry, there are no forces in ED or DC, because if there were any forces in these members, they would have to be transferred one direction or the other to something else. There are no horizontal forces, so this is obviously 0. And then this force, if it were transferred through this beam, it would have nowhere to go, so it's obviously 0 right away. Okay, now that we have calculated our forces and our reactions at our supports, we can start calculating our forces in our members. We'll use the method of joints. We'll start at joint A. From our free by diagram of A, we have a 6, 8, 10 triangle. We know that force in AE has a vertical component and a horizontal component, and so we're going to have to break it up. We'll get to that though. So we're going to take the sum of the forces in the vertical direction at A. So first we have a force of 2.5 kips acting in the positive direction, and then we also have the force at AE. Now by the sine rule, we know that the force at AE is equal to the adjacent, or the opposite over the hypotenuse of 6/10 times force at AE equals 0. So doing the math, we can find that the force in member AE is equal to negative 4.1667 kips. Now then, we know we also have a horizontal force in member AE, so we need to find the counteracting force in member AB. So we have sum of our forces in the horizontal direction is equal to, once again by the sine rule, or by a variation of the sine rule, 8/10 multiplied by our force in AE will give us our horizontal force. So 8/10 multiplied by 4.1667 plus the force in AB. Is equal to 0. Solving for the force in AB, we get 3.33 kips. Now then, that leaves one other member that we haven't found yet. That's the forces in member BE. So to do this, we'll simply use the method of joints at joint B. There's 2 horizontal members coming out of the sides, then member BE coming vertically from it. Now, we have 5 kips acting down. So, since these members can't carry any vertical forces, the force in BE is just equal to 5 kips. Now that we have our forces in AE, AB, and BE, we know that by symmetry, the force in AE is equal to the force in CE, and also the force in AB is equal to the force in BC. So now that we can start plugging numbers into the board. I already plugged in our AE force, which is also equal to CE. So, negative 4.1667. Now then, our force in AB is equal to 3.33. Which is also equal to our force in BC. Our force in BE, now there's still AF, CD, DE, and EF, but we figured out that those are simply 0 and that there are no forces in those members.